In the previous video, we discussed how to put square roots where the radicand is not a perfect square into simplest radical form. But if you had something like the square root of x squared, or the square root of x to the fourth, or the square root of x to the fifth, is there any way to simplify these? And there is. Let's start with the square root of x squared. The square root of x squared equal to the square root of x times x. Now if you'll remember, let's say when we have a number, the square root of 4, what we're trying to find is one number that we can multiply by itself that will give us 4. And that number is 2, so the square root of 4 is 2. Is there one number that we can multiply by itself to give us x squared or x times x? And of course there is. If we multiply x times x, then we'll get x times x or x squared. So the square root of x squared is x. So the square root of x squared is a perfect square. Let's try x to the fourth. What's the square root of x to the fourth? What is x to the fourth? X to the fourth is really x times x times x times x. Is there some number that we can multiply by itself to give us x to the fourth? Or some number that we can multiply by itself that will give us x times x times x times x. And there is. If we multiply x squared by x squared, or we multiply x times x times x times x, then we'll get x to the fourth. So the square root of x to the fourth is x squared. Let's try another one. We're going to skip x to the fifth for now. Let's try x to the sixth. What's the square root of x to the sixth? Is there some number we can multiply by itself that will give us x to the sixth? And there is. X to the third will give us x to the third times x to the third will give us x to the sixth, because when you're multiplying variables with exponents, if they have the same bases, you can just keep the bases and add their exponents. Let's try another one. What is the square root of x to the eighth? Is there some number we can multiply by itself to give us x to the eighth? And there is. If we multiply x to the fourth by x to the fourth, we'll get x to the eighth. So the square root of x to the eighth is x to the fourth. Now, by now you should be noticing a pattern. Whenever we had a variable to an exponent, let's say x squared, when we took the square root of it, the exponent of the new variable was half of the original one. When we had x to the fourth, when we took the square root, the variable of the new one was 2. When we had x to the sixth, the variable of its square root was x to the third, which is half of 6. When we had x to the eighth, when we took the square root of x to the eighth, we had our variable was raised to the new exponent that was half of 8, which is 4. So whenever you have some variable, square root of x, square root of y, square root of z, doesn't matter, raised to an even exponent, you're always, when you get your answer, it's going to be that base raised to 1/2 of the original exponent. Always. This is only for an even exponent. Now let's discuss what happens if we have an odd exponent. What would we do if we had a variable raised to an odd exponent inside a square root sign? Let's say we had the square root of x to the third. What x to the third really is, it's the square root of x times x times x. Is there some number that we can multiply by itself to give us x times x times x? So let's say we would decide that the answer might be x. Is x times x equal to x to the third? No, x times x is x squared, so this is not the answer. Maybe we'll decide that it's x squared. Is x squared times x squared equal to x to the third? It's not. X squared times x squared is x to the fourth. So this is not either the answer. So therefore we realize that x cubed is not a perfect square, but we can still put it in simplest radical form the same way that we put numbers in simplest radical form. When we had a number, like let's say 18, we want to take the square root of 18. Now we could try it on the calculator and find is 18 a perfect square, and it is not. So we're going to try to see if we can put this in simplest radical form. So we're going to do prime factorization of 18. So what's the smallest number that goes into 18 that's not 1? That's 2. 18 divided by 2 is 9. What's the smallest number that goes into 9 that's not 1? That's 3. 9 divided by 3 is 3. We take our doubles, circle them. One double stays out, and the singles go inside. So we're going to do the same thing over here. We're going to circle our doubles. We take one double out, and the other one stays in, and everything else stays in. So this X in red didn't have a double, so it stayed in. The X's in green, these two were a pair, so one of them came out. Let's try another example with an odd exponent. Let's say we have the square root of x to the fifth. What this really is, x times x times x times x times x. And we're going to put it in simplest radical form. Since it's an odd exponent, we know that it's not a perfect square. We're going to circle our doubles, one double, two doubles. We take out one from each set of the doubles, so we have double greens, we have double oranges, and we only have a single pink. So we're going to take out a green, we're going to take out an orange, and we're going to leave a pink inside. The x is on the outside. We can multiply x times x. The green x times the orange x becomes x squared, and we leave the pink x inside. So x to the fifth is equal to, in simplest radical form, x squared square root of x. Let's try another one. The square root of x to the seventh. We're going to do the same thing we just did. X to the seventh is equal to 1, 2, 3, 4, 5, 6, 7. X times x times x times x times x times x times x. We're going to circle our doubles. Double, double, double. So here we have three doubles, so we'll take out three x's, or x to the third, and we'll leave one x inside because we have one green x without a match. Let's try one more. X to the ninth. It has an odd exponent, so we know it's not a perfect square. And what's x to the ninth equal to? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's circle our doubles. 1, 2, 3, 4 doubles, so we have x to the fourth outside, and we have one single that doesn't have a double, so we're going to keep that one inside. So x to the ninth is equal to x to the fourth square root of x. So let's see if we could come up with a rule for the simplest radical form of a variable, the square root of a variable that has an odd exponent. We discussed that when you have the square root of a variable with an even exponent, it becomes that variable to 1/2 of the exponent. What happens if you have the square root of x to an odd exponent? We rewrite the problem as the square root of x to the even exponent right below that odd exponent times x. Then we take 1/2 of the even exponent and we bring it outside, and we leave the square root of x inside. So let's see how to actually do that. We'll keep the x to the fifth on the screen because we'll try it on that one. So x to the fifth, we already solved for x, that x to the fifth is equal to x squared square root of x. How do we solve it using this rule? So the square root of x to the fifth is equal to, we want to find the even exponent right under x to the fifth, which is x to the fourth, and then we have to multiply by x. And this is the same thing, x to the fourth times x is the same thing as x to the fifth, so we just rewrote it in a different way. Then we take 1/2 of this exponent, 1/2 of the even exponent, which in this case is 4. We take 1/2 of that and bring it outside. So outside we have 1/2 of 4 is 2. So we have outside we have x squared, and inside we still have that x. And we got the same answer. Let's try it with the square root of x to the seventh. We're going to rewrite this. The exponent right below x to the seventh would be x to the sixth. And and we have to multiply by another x. X to the 6th times x, it's really x to the 1, is the same thing as x to the 7th, which is equal to, we're going to take 1/2 of the 6 and bring it outside. So 1/2 of 6 is 3. X to the 3rd, square root of x, which is x to the 7th. Let's do one more. The square root of x to the 9th. We're going to take the square root and rewrite it as x to the 8th times x, because we took the exponent right below the 9 is 8. We multiplied it by x. That's equal to, we take 1/2 of 8, so that's x to the 4th. We take it out. We leave the square root of x inside.